Welcome to the DIY Honda Garage channel. The diagnostic trouble code, DTC P0107, indicates a low voltage condition from the manifold absolute pressure MAP sensor circuit in a Honda Civic from the years 2016 to 2021. The MAP sensor is critical as it measures the pressure within the intake manifold, allowing the engine control module, ECM, to adjust the air-fuel mixture. When the registered voltage falls below the specified threshold, which is typically less than 0.23 volts, the system triggers the DTC to alert technicians of a potential issue. Proper functioning of the MAP sensor is crucial for maintaining optimal engine performance and preventing undesired engine operating conditions, such as poor fuel economy or increased emissions. This fault may also affect the vehicle's drivability and overall performance, making accurate diagnosis and repair essential. The MAP sensor is located in the intake manifold of the Honda Civic and is responsible for providing real-time pressure readings, which allows the engine control module, ECM, to determine the appropriate air-fuel mixture. The sensor operates by sending a voltage signal to the ECM, which adjusts engine parameters for optimal performance. When the voltage is low, specifically less than 0.23 volts, it indicates a malfunction in the sensor or its circuit. The ECM, housed within the vehicle, interprets this data to make adjustments essential for efficient engine operation. A failure in this system could lead to various drivability issues, emphasizing the need to understand the components and their locations as part of diagnosing the problem effectively. Several issues can contribute to DTC P0107 being triggered. Poor electrical connections may arise from corroded terminals or loose wires, disrupting the voltage signal sent from the MAP sensor to the ECM. A faulty MAP sensor could simply be malfunctioning, leading to incorrect voltage readings. Additionally, damaged wiring or shorts in the circuit could prevent the sensor from operating correctly, resulting in low voltage. Understanding these potential causes is crucial as they provide a roadmap for troubleshooting effectively. Each cause presents specific symptoms and testing methods that can guide technicians in identifying the true nature of the problem. When troubleshooting DTC P0107, certain symptoms may be evident during operation. Engine performance issues can manifest as hesitation, stalling, or erratic acceleration, primarily stemming from incorrect air-fuel mixture readings. The check engine light will typically illuminate, signaling the driver that a fault exists, prompting the need for a diagnostic check. Poor fuel efficiency is another common symptom. The ECM, working without accurate sensor input, may lead to excessive fuel consumption. Recognizing these symptoms is vital as they help prioritize the troubleshooting steps and may guide technicians toward a quicker resolution of the underlying issue. In the first troubleshooting step, begin by turning the vehicle to the on mode without starting the engine. This allows you to assess the status of the MAP sensor using a Honda Diagnostic System HDS tool. Once in on mode, check the voltage reading from the MAP sensor. According to the diagnostic protocol, the voltage should register less than 0.23 volts under current conditions. If it meets this threshold, it confirms that the failure is present, leading you to proceed to the next troubleshooting step. If the threshold is not matched, the issue may be intermittent. Therefore, checking for poor connections or loose terminals at both the MAP sensor and the engine control module, ECM, is advised. After obtaining the voltage reading, the next step is to turn the vehicle off and disconnect the MAP sensor's 3P connector. With the sensor disconnected, turn the vehicle back to the on mode to recheck the voltage level. Again, using the HDS tool, the voltage from the MAP sensor should register less than 0.23 volts. If the reading confirms this threshold, It indicates that the system is functioning correctly in terms of wiring, and the issue likely lies within the sensor itself. However, if the reading does not match, it suggests further troubleshooting is necessary, leading to the next testing step. This systematic approach allows for the identification of the fault area with precision. In this third step, keeping the map sensor disconnected, measure the voltage between test points 1 and 2 on the map sensor's 3P connector. This step is crucial as it informs whether the expected voltage of approximately 5.0 volts is present. Ensure the vehicle remains in the on mode during this test. If this voltage is detected, it confirms that the circuit provides sufficient power and indicates a malfunctioning map sensor. In this case, replacement of the map sensor is warranted. If the 5.0 volts are not present, the next step would focus on testing for an open circuit, leading to deeper investigation of the wiring connections involved, ensuring the circuit integrity as a priority. For the fourth step, turn the vehicle to the off-lock mode and jump the SCS line with the HDS, waiting more than 1 minute to clear any faults. Next, disconnect the PCM Powertrain Control Module, Connector E, which contains 80 pins. The key task here involves checking for continuity between the relevant test points while ensuring the map sensor's connector is still disconnected. Testing this circuit determines if there is continuity in the VCC1 wire connecting the map sensor and the PCM. If continuity exists, it indicates that the wire is not damaged. If the test reveals no continuity, it signifies an open in the VCC1 wire, necessitating repair work to restore functionality before proceeding. In the fifth troubleshooting step, you will again turn the vehicle to the off-lock mode and jump the SCS line with the HDS monitoring tool. Disconnect the PCM connector E 80P once more. After this preparation, assess for continuity between test points established at the map sensor and body ground. The goal here is to determine whether there is a short circuit in the PB wire between the map sensor and the PCM. Finding continuity means that the wire might be shorted and requires correction. If the PB wire is confirmed to be functional, you should check authorized service information under DTCs or symptoms and consider substituting a known good PCM to recheck how the system responds to this change. Should the DTC clear following this substitution, it indicates the original PCM requires replacement. Final repair verification is critical in ensuring that the previously diagnosed DTC P0107 has been adequately addressed. This process begins with a confirmation check of the DTC codes using a diagnostic tool to verify that the fault code has cleared. If the code still persists, further investigation may be necessary to ensure all aspects have been addressed. Following this, a test drive of the vehicle is essential to understand how it operates under real-world conditions, ensuring that any performance issues have been resolved. Once the drive is complete and no error codes are present, it confirms that the repair was successful. Documenting the findings and resolutions can assist in future diagnostics and enhances the ongoing maintenance of the vehicle. Preventive maintenance plays an essential role in vehicle longevity and performance, particularly regarding the map sensor and its associated circuits. Regular electrical inspections should be performed to identify any signs of corrosion, wear, or loose connections that could impede performance. Keeping connectors clean is another significant preventative measure. Dirt and grime can create barriers that interfere with electrical signals. Furthermore, routinely monitoring the performance of the map sensor can help catch potential issues before they lead to faults, such as the DTC P0107. Proactive inspections can help avert more severe problems and costly repairs down the line, ultimately ensuring reliable vehicle operation. In summary, understanding the role of the MAP sensor is paramount for diagnosing and resolving DTC P0107 effectively. Adhering to systematic troubleshooting steps brings clarity and precision in addressing faulty components or circuits. By identifying voltage discrepancies and ensuring circuit integrity, technicians can accurately determine whether a sensor replacement or rewiring is required. Furthermore, engaging in regular maintenance practices can significantly mitigate the likelihood of encountering similar DTCs in the future. This holistic approach not only enhances vehicle performance, but also promotes greater reliability and safety for Honda Civic drivers. Please like and subscribe to the channel. See you next time.